All right, we're gonna go fast. Chris Malone from Winona State, which is a couple hours that direction, 3 hours that direction. Just a little bit about Winona State. We have 7,000 students. Numbers going down actually a little bit. Kind of happening in a lot of places. But we're good. The number of students in our statistics program is going up, and the number of students in our data science program is going up. So we will be hiring another person. We have 7 right now, and hopefully we'll get to 8. Not next year. We'll have to wait another year. But anyway, so I'm going to tell you a little bit about data science, kind of as a big picture, and then focus in on how we got involved with it at Winona State. So if you go back and look at what statistics, this is on Wiki. A lot of people argue over what the definitions are for data science and statistics, and I don't really need to, I don't know what they are, to be honest. And I don't really care. But on Wikipedia in 2013, statistics was the science of data. In 2015, statistics is the study of collection, analysis, interpretation, presentation, and organization of data. And basically what happened here is, well, and then in 2019, it's pretty much the same. So it really hasn't changed. There was a change there from 13 to 15. Okay, and what came on board there was data science. So data science kind of come in and said, we need to get in here too. So in 13, statistics was the science of data. And in 15, data science got on Wikipedia, so I don't know if that's when it started or not, but whatever. They got in there and said, I need some room too. Okay? And it really hasn't changed from 15. So let's just think a little bit about what data science, kind of go way back here. I'm trained as a statistician. I've certainly enjoyed the computing side of things. So my take on this is going to be from both of those sides, I guess. So data science really is not just the merging of those two things. I'm missing something very important here, and that's the interdisciplinary component of data science. Okay, so that should be in here. You'll see it in our curriculum, but it's not here in this picture. In 1962, John Tukey, he's the guy that invented box plots, had a paper about what data analysis should be. And this is kind of interesting because this is, well, we didn't have computers. So it's kind of hard to do data analysis without computers. But John Tukey wrote about that. And then on the CS side of things, we had people talking about data processing. So that's when our computing started to come on board. In the 80s, there was a lot of information about databases. And then in the 90s, there was a lot of the data mining type stuff. Okay, so it was kind of brewing over there on the computer science side as well. 2001, I'll just jump to one. Bill Cleveland, he worked at AT&T. He said he started using the phrase data science, an action plan for expanding the technical areas of the field of statistics. Okay, so that was, 19 years ago. We didn't really get going until 15. So we wasted 15 years, I guess. How about at Winona? We did a program review. So we have a statistics program as well. The statistics program has been there since the late 80s. So I'm very proud of it. We have a very robust program, I guess. And it has served students well, I believe. So we had a review, statistics program review in 2010, and what the reviewer asked basically was, well, you're doing a really good job of sending your students to graduate school. So about 40% of our students go to grad school, but you're not doing so good for the people that want to go out and get a job. So we did some reflecting. We started thinking about what we would need to change in our statistics degree. That's the breakdown for grad school and employment, a 4 to 6 ratio there. So we decided to go out and just conduct a bunch of interviews. Okay, so we went out to spend a summer of 11. I think we had 19 different interviews. We were driving the cities 2 days a week there for a while. And we basically just, if you don't mind, just handed hiring managers a blank sheet of paper and said, what skills do our students need? Okay, we had a nice hour meeting. Okay, wrote it all down. And then we took that paper and we just threw it away because we didn't like what they had to say. So that's not what we were doing. And then we, went to the second interview because we interviewed 20 different people. Same thing, we had to throw that one away too because we didn't like what they were saying. But after about 5, you start to realize, or 4, where your pride's at, but we're not doing it right. So we had to think about what could be different. And we were really worried about that right side there. We wanted to kind of keep what we had, but we were worried about trying to make that right side a little bit better. So we decided that we had to do something different. Okay, so this is 15 is when data science showed up in Wikipedia. We were starting to do this in 12, 13 is really when a lot of the work got done. We weren't the first. College of Charleston, South Carolina, claims to be the first undergraduate data science program in the country. Anderson was his name. Sent him plenty of emails there trying to pick his brain about what they were doing down there. So we ended up creating this degree in 2014. So what does this degree have in it? And how has it changed? That's more important. How has it changed? It's really broken down into 3 pieces. Got an analytical component, computational component, and an interdisciplinary and professional skills component. We heard a lot about people just aren't ready to be in a job. Okay? So we really took the professional skills thing to heart, followed some work that was being done at Duke at the time, and built up a couple of courses around professional skills. So the balance there was important. Okay? That's what we heard over and over and over, that we really wanted about 1/3 in each of these areas. So what is the analytical part at Winona State? I'm talking to the data science program now. Statistics program is a different topic. You have to take a year of intro stat. So we believe that a year of intro stat is a minimum. Okay, anything in our program requires a year of intro stat. Calculus gets 3 courses. Can't stat get at least 2. That's kind of what our philosophy was. So a year of intro stat, and then the regression course is required. We had some math in there, but we really brought that math down. I'll talk a little bit more about this at the end. We brought the math too low. We took out too much math in our data science program. So we're putting back in another course. And then we had a year of intro data science as well. On the computing side, we had 4 courses over there from CS. Okay, and this was an important component that we wanted, is not us teaching the computing, but having computer scientists teaching the computing. We thought that was important. And then, so intro, a year of programming, they were using Java, and then applied database management. And then we had a course in the management of structured data that we carried. Actually, that was a statistics course, and we scooted that over into the data science curriculum. And then as far as the interdisciplinary component, this was difficult for the school more than anything, but what we wanted is just any discipline. Okay, so we didn't care what discipline you wanted to apply your data science to. It could be anything. But you had to have a decent number of courses in that discipline. You couldn't take 1 finance, 2 economics, and then a marketing and call that an interdisciplinary emphasis. We wanted you to take 4 courses in marketing. So you had a good solid baseline there. Now the school didn't like this because this was a nightmare to decide whether or not, in our systems, to decide whether or not they met the degree requirements. Okay, that was not something that they were very happy about, but we pushed it through. And then skill development, and then the Capstone experience. So the R there just stands for required, E will be electives. That's the number of credits there. And then we have electives as well. Those electives can come from either side. We don't care. So we really spend the first couple of years building that analytical and computational stuff. So the intro to stat there is that first couple of years. The intro to data science sequence is the first couple of years. All right. The computing, the year of programming from the CS sides in that first couple of years. And then they can start building up that interdisciplinary part and at the top graduate. So let's talk a little bit about what's in that intro data science course. We're not going to spend too much time on this. Data cycle, a lot of that, programming with data, foundations of data processing, things like that. Programming with data, I don't care what language you do it in. Our goal is to get software agnostic here. We want to get to software agnostic as fast as we can. I don't really care if you like Python. I don't care if you like R. I don't even care if you like Excel. All I need is a job done. Okay? So you can't quite be that bold because they have to learn those tools, but that's where we'd like to get to. We do a little bit of just fun things in that intro to data science course, otherwise they'd be bored to death, right? Data management's not a lot of fun, but fitting an association rules, doing an analysis like that is fun. Classification trees, we do. Those are the things that are available to do in that intro course. So baby machine learning is done right away, just to try to get their excitement up a little bit. And then we got the visualization course. Basically, we spend about 4 weeks or so in the foundations of visualization. So things like EPTs, if you've heard of those, or Gestalt principles, how to use color effectively, design elements of what a visualization should entail, lots of critiques, and then most of that course is just visualization projects. So they do big visualization projects throughout the second half of that course. We take advantage of the American Statistical Association data challenges every year. This year it's on homelessness, so we will do a project centered around homelessness in that course. Okay, catch your breath. What are we changing? We're 5 years old now. So we're just big enough to be able to run around pretty good. And we've decided, we went through another program review. So now we're kind of on the other side of that, thinking about what we need to change. We took out too much math. So we said either applied calc or calc 1. We could have said calc 1, 2, 3, but that's a pretty big bar. We didn't really want to go there. But you need that math maturity when you get into the machine learning. You need a little bit of linear algebra type stuff as well when you get into that machine learning. So we're bringing some of that linear algebra back in now. We're going to do some optimization stuff and also some baby probability stuff. So that course is not on the books right now. That was a goal for us for this year, is to develop a course called Math for Data Science. Question about whether or not we'll make our statistics majors take that? Probably, but I don't know that for sure. For sure the data science people are going to have to, students are going to have to take that. And then we got our that's our machine learning course. We are moving that from an elective to a required course. We wanted to keep the degree kind of light when we were starting, just to make sure students would come and not see it as a barrier. So I think we were around 60 or 63 credits when we started. In contrast, computer science was at 80-some, I think, at Winona State. Okay, so we wanted to make sure and make it attractive, something that the students could be drawn to, I guess. So now we're moving that to a required course. CS kind of got rid of their intro to algorithms course. Wasn't really working out as well as they brought that on about when we were developing the data science course. So we're taking that off the books. I think they still have it, but not very many students are taking it. We had a management of structured data, and we now have created a management of unstructured data. So just more about the data management stuff. Data science at scale, we were missing a course. We knew that when we started. You can't develop a new program at a public university and then walk to them and say, I need 8 new courses. That doesn't work that way. So what we decided to do is go to them and say, we need, I think we had 3 or 4 new courses, okay? And we knew we would build those up over time. So we have this data at scale course now that's on the books, which is a good addition. We also have an unsupervised learning, so we have a year-long sequence of machine learning now. I think we're going to keep this one as an elective, though. So what has kind of changed from 2014 to now? The statistics had a year-long sequence of introstat and regression. Okay, that really hasn't changed. Other than we're more aware that we have data science majors in our regression course. So we've kind of modernized that course a little bit to help those students. We've added 3 courses in math. We've added some elective classes and moved some things around in data science. We ended up dropping a CS course there, but we also added that data at scale course. So that's a lot of just programming in there. So we feel comfortable that we're getting enough of the computing, computational aspects of the degree in there. Interdisciplinary, that hasn't changed at all. Professional skills, I guess I failed to mention the professional skills. We have 2 courses just on professional skill development. They're taken as, the first course is taken the spring of their junior year, and then the second course is the spring of their senior year, which really just try to work on their professional skills. We have speakers come in and things like that. Advice. So if you're teaching in a data science program, okay, what do I believe? Become software agnostic. I had a conversation last night. Somebody was Python or R. The question was, is it Python or R that you use? And somebody else was standing there and said, why is it or? Why can't it be both? I totally agree. I don't really care what you use. Okay? Just get the job done. Really build foundational thinking. We are a science. Okay? We purposely chose the name data science. So we had to have that foundation in there. So we're pretty aware that we want to build that into the program. Consider your non-programming options, especially when you're starting. Do we really need to use R in the first course? Or is it more important that they can manipulate data in the first course? Okay. Do I need to be able to do my visualizations in Python? Or can I do it with a drag and drop program? I think you can do it with a drag and drop program. When you're teaching the foundations of visualization, you don't have to bury them in code as well. Code's hard. Let's separate those two. What are the foundations of visualization, and then what is code? There's no reason we always have to put those together. I think that's just creating barriers for students. Internships, internships, internships. Students need to get out there and apply what they are learning. Okay, we have really tried to push that in both our statistics and our data science. It's much more common in data science though. Build relationships with companies in your area. I was just talking to Denise, who was at Century, is it? What's the insurance in town here? Century? They have a strong connection here, from what I understand, with the data analytics program here. Okay, each school should be doing that we can put students out there and get those students practical experience. Get students involved. There's different data competitions. We run one down there at Winona, which has actually moved to Mankato State now, called MUDAC, Midwest Undergraduate Data Analytics Competition. We've run that thing since 2012. Get involved with those things, or have your students get involved with those things. We hear this a lot, or at least I hear this a lot. Who's going to teach this stuff? You are. If anybody is an expert in learning, it's you. I mean, it might be kind of hard to take this brain here and go back to my 20s. It might take me a little longer to learn, but I can still learn. Okay, you just got to be able to feel that you can do that. You gain the confidence that you can do that. And it's scary. Okay, the first time I taught Intro to Data Science, I did not know what I was doing. I didn't have a book to go to. I was just making stuff up. Okay, it just gets better over time. So give yourself the confidence. Work with colleagues. If you're lucky enough to have colleagues like I am, we divided and conquered, and then make connections with working professionals. I don't think can be estimated enough. That's all I got. Questions? Yeah.
I think you had that they get a capstone experience. Can you describe what they're doing there?
Yeah. So there's a capstone requirement there. An internship will serve as a capstone experience. We did not want to require internships back in 2014 because we had not. What do you do with the students that maybe shouldn't be out there quite yet? Okay. So we allow them to do other types of projects. So they can do a big data project if they want under our supervision. I would say that maybe 2 out of 10 take that. Most of our students are going out and getting internships. They have to go through some experience where they're doing all the work, they're creating the product, the end product, just under the direction of someone. And you got to be a little bit careful with the internships. Sometimes you send people out and all they're doing is just reporting stuff, or they're really not gaining much knowledge. They're just kind of somebody's data monkey, or whatever the right term is. So you do got to kind of, we've learned that we're going to have conversations with these people that our students are going to be working with. We have evaluations now, evaluations that the folks out in the industry do of our students. So yeah, those are very important, I would say.
The students that do the internships, do you have them come back and like give a talk about?
That's part of the professional skills senior course is that requirement that you have to present your capstone.
Is there credits associated with that?
Yeah.
Capstone?
Yep. 3, variable credit, minimum of 3.
And what is the general, the whole degree, data science? How many credits is that?
We are up to, I think, 68 or 66 now. Wow. We're bringing math back in. We're starting to make some of those electives required. So we're upping that number a little bit more now.
And also another question, have you do you have any problem recruiting students for you?
No.
There's trouble sitting out?
No, we are not. I have a hidden slide in here, but I don't know if I project that. Does that stay hidden or does that go up? That works. So, no, not at all. We thought that this right side, which is data science, would take away from our left side, but it hasn't. We are gaining new students. Okay, so somehow we are pulling in a different student into our programs again. They're mostly CS.
In the statistics, in the statistics part, how many credits was that
It's very similar. It's in the
It's
mid-60s.
about 60s.
Yeah. That one on the left has been there since 1988, I think. And the one on the right started in 14. I didn't get the numbers for this fall. One thing that has helped this is the department has done a much better job of trying to recruit high school students at Winona State. So next Tuesday, I think we're bringing in like 130 high school students from around the region to tell them about careers in math and stats and data science. So these numbers have gone up in our department as well. I saw more hands. No? Yeah, go ahead.
I work at Century alongside Denise.
Yeah.
And one thing that we see with our interviews, and I'm curious if when you were doing your interviews in that summer of 2011,
Yeah.
were they saying things of, for us, data is dirty. It takes a lot of work to get the data there versus just doing the fun modeling stuff. Is there a realization that that ratio of prepping data and actually modeling?
That's a very good question. I meant to mention something like this.
Sometimes.
Yep. So what the faculty like, okay, at least in my experience, in the 5 years I've been running around barking about this program, what the faculty like to do is the interesting modeling stuff. Okay, so almost always programs start with, I need a machine learning course. Okay? And you can ask folks out in industry or ask your alum, how much machine learning do you do? They're like, not very much. So it's like, I don't know what the number is, I don't really care, but it's like 80% on data preparation, data cleaning, yada, 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 yada. Maybe some machine learning, but probably not if you're an undergrad. You're probably gonna hand it to somebody and then they're gonna go do the machine learning thing. So your courses got to emphasize the data preparation stuff. So we have, let's see here, I'm gonna call DSci 210, call that half data preparation. DSci 325 is all data preparation. DSci 330 is all data preparation. So what am I up to? And DSci 430, that's data at scale, but that's all just playing with data, not modeling anything. So we're up to 3.5 classes on data preparation, okay? And only one required machine learning course. So we think we got that in balance, but I think we can, I mean, that's something you gotta worry about. Good question, thank you for bringing it up.
When you open up the lecture, you talk about your interviews with businesses and how you're delivering.
Yeah.
How's the feedback now, and what sort of jobs are your students going into, or are they going, is that ratio between grad school and business, how's that working?
So in stat, it's gone up a little bit, okay? Because the people that want a job will tend to go towards the data science degree. So I would imagine that half of our stat grads are now going to grad school. But on the data science side, very few are going to grad school. A, because I don't think those programs are necessarily out there as well as the other ones. And the other negative is they don't pay. When we send students to graduate school in statistics, it's a free ride. Okay? Data science programs aren't doing that yet.
So how is the employers, I'm talking from the employee side, with the jobs, the people who hire your data science grads, how are they feeling like they're well prepared, and what's the feedback on that?
Yeah, I think we're doing okay. Most of our students get jobs through their internships, so which is a good sign for us. Because if they're going out there and they're liking what they're doing, they're gonna ask them to stay. Okay, so I would imagine, I don't have a number on that, but 3 out of 4 are probably just curtailing off their internship and then starting, which is nice because they get jobs the end of their, or beginning of their senior year, right? Often, which looks really good for recruiting.
At what point in the degree program are they typically going out to internships?
Usually after the 3rd year.
After the 3rd year?
We can send some of our better ones after the 2nd, but it's usually after the 3rd.
So they don't yet have quite enough skills to start internships after 1st year?
No, not after 1st year. Because they take a lot of that foundation stuff, so they're gonna be buried in a year of Java, a year of stat. You know, the data science stuff, the DSci 210 and DSci 310 is where they really start to play with cleaning up data and visualizing. DSci 310 is our visualization course. It's very popular. I think that's a good course. I think people appreciate that out there in industry, that our students can take a Tableau and do something with it. Good questions. Yeah.
I was just curious, just a rough estimate, percentage of female versus male?
We are lucky enough at Winona to be very strong in nursing and elementary education. So I think it's like between 65 and 70% of our students are female. So our proportions are
What
much
about
higher
in your
than.
data analytics program?
Yeah, it's up there. It's probably half.
So 50%?
Yeah.
What are you doing to attract them?
We do a lot with, well, over time, what we've tried to do is convince people that data science is really about telling stories and helping other people. You don't do data science just to please yourself. You're always out there trying to solve somebody else's problem. So we really emphasize that communication stuff. We really emphasize the teamwork, some of those things that females connect more with. But I think the driving thing is the fact that we're starting with whatever it is, 67% female on our campus.
See, so nationally, what is it, 55% of collegiate campuses and growing.
Perfect.
That number is expected to actually get up to about 60-65% of all college campuses, like the associates through female by 2026, because guys aren't going into
Yep.
post-secondary education at
Yep.
all. So I'm not sure that's a great correlation that, because you have 65% females on campus, that's why you have.
Yeah, that-
I'd be interested to understand really what is so unique about your program that you're getting so many females in the data analytics. It's great.
Right.
Especially given that 20% tends to be the national standard across.
Yeah, I've always just attributed it to that we're starting way further
Yeah.
ahead, but we have not studied. I mean, we should. Why, ask the
NC WIT has some great data
What was
on
it?
National Center for Women in Technology.
Okay.
Has some great data on attraction, retention, and not just through, like, up through the educational pipeline, but even into the workforce. So
Mhm.
we see roughly 50% dropout of women from the IT sector after they actually start their careers.
Oh, wow.
So another thing that we're working on the east side of the state is what do we do to help build resilience, retain the women once they're in.
Yep. As somebody that has 4 daughters, I appreciate the work.
I have 3, yep.
I have 1 minute, they're telling me, and then the next week, oh, we have break, don't we?
Yeah, there's a break.
All right, we don't have to,
But-
we can ignore that sign now.
One more question. You are saying, well, you don't have any problem with recruiting. Who actually is doing the recruiting?
We are,
Do-
the department.
The department itself
Yeah.
is doing the recruiting. So what type of funding it has in terms of, how you do that with your teachers, you do the teaching?
So, probably about 5 years ago, we started to feel that we weren't doing the best we could in that area, so we went to the admissions office and just said, we want to tell you about what we do, okay? So that you can inform others about what we do. We had a big launch of the data science program on campus. We had the president of the American Statistical Association come in. I had known her through some other work, so it was a big deal. Invited all the admissions to come over and learn about what data science was. Not one came. Just fine, they're busy people, I understand. But we realized that in order to do the recruiting, we had to do it. So we now ask for anybody that has shown an interest in any of our programs. We get those lists, we get their addresses, okay? Anybody that has done well on like ACT, okay, so if they meet a certain threshold, we get
But the
those.
admission is providing you with
Yep.
that information,
Yep.
so, okay, so.
Yep. And then we just work our butts off to do things to try to draw them in. Send them t-shirts, send them flyers. Do you know what data science is? Because you might not. Okay? This might be a career that you are interested in. So very aggressively going after those folks. And it is a lot of work. We have a recruiting committee now that works their butt off. Probably one of the busiest.
In your department, you
Yeah.
have a recruiting committee that is,
That's all they do.
they go over the.
Yeah.
What's the typical nature for the students that choose to get a minor in your data science program?
Probably computer science.
Okay.
We are, one area, and I hope to build business. So one thing that we've been talking about with the finance group over there at the business school is business analytics. I think we're ready to try to make a bridge there. It probably is going to require maybe some different courses, maybe not quite as aggressive on the programming side. But we'll have to work through that. We're starting those conversations. We just had a meeting last week that, what is it, health leadership. They want to consider an analytics degree in healthcare. So it might be time that we start developing these kind of service courses in data science for other programs. I think we could do that. Yep.
For your high school students coming in Minnesota, are they all getting statistics in high school?
No.
No.
Very, I don't know what the proportion is, but it is not. I can speak to where my kids go. They take 4 years of math, and the optional statistics course, I think, is 10 weeks or something, and that class has maybe 10 students in it. Because the person that's teaching it is, it's not a statistician. It's hard to teach something that you're not passionate about. In my experience, the people that are most passionate about statistics are your science teachers, not your math teachers, your science teachers. Because they have to do the stats in their write-ups and things like that. So I think I'm over time. I'm sure I'm over time, so let's go out and enjoy our break. Thank you for coming and thank you for listening.